Okay, folks, how we doing? So check out the website we went to. It's this Daniel Sloper. There's a link that I placed um, in that little section of Canvas there. Okay, so notice that sometimes they don't give us the raw data. They give us the summary statistics. They give us the X bar, the mean, the sample, standard deviation S, and the sample size N. And our calculator can't handle that. Our calculator wants raw data. So if they give us summary statistics, we just go Google ANOVA calculator, and I found this one that's pretty good. Daniel Soper, don't know who that is, but he has a nice little ANOVA calculator here for us. So group 1, let's see, number of subjects N, it's 5. The mean was 10, standard deviation of 1. So just be careful when you're putting in the data. Next group, number of subjects was 5. That's all 5 and 1. So 5. So then the mean was 12, 1. Next group, 5. Mean of 8. Standard deviation 1. 5. 14. 1. And then you just hit calculate. Boom. And it does all the work for you. And notice how it creates this weird little table down here. The between, the within. We'll talk about that in a second also. But notice that it did give me an F of 33.33 and a p-value. So here's the F. That's my F test statistic. And then a p-value of about 0.000. Okay. So we're going to bring that over to our standard 6 questions and just answer all the questions. But let me point something out to you really quickly. This is getting into problems number 3 and 4. So you can see here, sum of squares, SS is sum of squares, MS is mean square, DF, degrees of freedom. How many groups did we have? 4. Okay, so if you have 4 groups, the degrees of freedom is probably 3, one less. Aha. And then there was 5 subjects, 5 subjects, 5, 5. So that's 20 people or things all in all. So degrees of freedom would be one less. 19. Ah, okay, I see. And what is 3 plus 16? 19. Or if you needed to figure out that 16, what is 19 minus 3? That's the 16. Okay. Notice also that our sum of squares, they're complicated to get, but notice that 100 plus 16 is 116. Okay. And then here's where the table gets weird. What's 100? Now it goes weird to the right. What's 100 divided by 3? 33.333. Okay. And then second row going across, what is 16 divided by 6? 1. Okay. And then this last one's kind of weird. You're going to divide these mean squares. What's 33.333 divided by 1? 33.333. Oh, okay. So, so I just quickly pointed out the relationships within the table, and that's what we're going to use on the next problem, just sneaking ahead. But I did want to point out that there are relationships within this table. And remember, back in the day before calculators, in order to figure out the F statistic, it took a lot of work, and you'd have to set up this table. Okay, let us continue from here. Okay, so from the Daniel Soper website, that ANOVA calculator, we got a test stat of F equal to 33.333 repeating and a p-value of approximately 0. And then in this problem, our alpha is 0.5. Alpha of 0.5, that's my alpha. Let's see. So my p-val is less than my alpha. If p-val less than alpha, that means we need to reject the null. Whoops, left it blank. Okay, so just like problem number 1, the null, how many groups do we have? Let's see. Sample A, B, C, D. So there's 4 groups. So the null hypothesis would just be mu1 equals mu2 equals mu3 equals mu4. Okay. And then the alternative hypothesis, H1 or HA, should be pretty easy. It would just be, at least one mean is different. Aha. At least one mean is different. At least one mean is different. Okay. Good, 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 good. Reject HO, reject HO. So if I say reject HO, then that means evidence suggests. Evidence suggests the HA. Evidence suggests, put it into English. Oh, it already is? Cool. Evidence suggests at least one mean is different. Yay. Okay. On to problem number 3.